Alright guys, so welcome to another video lesson. Today we're going to go over the Pythagorean Theorem and how to find the hypotenuse. The Pythagorean Theorem describes a special relationship amongst the sides of a right triangle. The most important thing about a right triangle is that there's a right angle. We're going to be able to use a quick theorem / formula to find the missing sides, missing legs, or the hypotenuse. So on the screen you'll see a right triangle. Again, the first thing I want you to do when you're looking at a triangle is find, if it is a right triangle, find this little mathematical symbol right here. That indicates that that is a special right triangle. The two side lengths that is connected to the right angle are your leg A and leg B. It doesn't matter which one you call leg A or leg B. The cool part is opposite of the right angle is called the hypotenuse. Hypotenuse. Again, I already drew it on there for you, but first thing you need to do is find the right angle. Here it is. Connected to it is my leg A, leg B, and opposite of that is going to be my hypotenuse. Okay. Another example of it. It doesn't matter how the triangle is flipped, but as soon as you can find the right angle, you know that opposite of the right angle is my hypotenuse, and then my two side lengths that is connected to my right angle is going to be called my legs, leg A and leg B. And again, it doesn't matter which one is leg A or leg B. So let's jump right in. The Pythagorean theorem is an equation that shows the relationship between the legs and the hypotenuse of a right triangle. It is a squared plus b squared equals c squared. We've been talking about this a squared plus b squared equals c squared for a while now, and I guarantee you ask your parents or your friends, what does a squared plus b squared equal? More than likely, the people are going to say c squared. But now we're finally going to use it, apply it, and see how it works, and it's pretty cool. So here's the first example. Find the length of a hypotenuse of a right triangle. How do you know this is a right triangle? Find that right angle. Here's the right angle. I know that immediately opposite of that, this is called the hypotenuse. So this is a variable right here next to the hypotenuse, so I know I need to find the hypotenuse. It also tells me in the question. So they give me leg A and leg B. Step 1, always write down the theorem or the formula. In this case, it's a squared plus b squared equals c squared. And then go ahead and drop in your parentheses with the squared. Okay, and then you just substitute in the numbers. So here I have 5 squared plus 12 squared equals c squared. And again, we had you memorize the first 15 squared because it goes by pretty quick. So 5 squared, 25, plus 12 squared is 144, is equal to c squared. Again, I'm looking for c, but I have to square it first to find c, and then I'll show you that in a second. 25 plus 144 is 169, is equal to c squared. Now, like in mathematics, we talked about this last week, c squared, something being squared, the inverse of that or the opposite of that is to take its square root. So what I'm going to do is I'm going to square root c squared, and it's going to give me c. Why? Because I know that c times c is c squared, is equal to, if I square root one side, I'm going to do it to the other side, just like when we're doing adding and subtracting or dividing and multiplying on both sides. The square root of 169, luckily we know that, is 13. So c is 13. This is another example. Find the missing side of the right triangle in the 1 centimeter grid below. This one's just on a grid. If you want to pause the video right now and try it, go ahead. I'm going to go ahead and do it. Step 1, write the Pythagorean theorem down, which is a squared plus b squared is equal to c squared. I'm just going to put in my parentheses squared plus squared is equal to c squared. How do I know I need to find the c squared? Because here's my leg A, leg B, here's my right angle, which gives me the 90 degree. Opposite of that is going to be c, or my hypotenuse. It doesn't matter which one. I'm going to go with 6 squared plus 8 squared equals c squared. 6 squared is 36 plus 8 squared is 64 is equal to c squared. 36 plus 64 is 100 is equal to c squared. To get c by itself, In other words, c squared means c times c, so I have to do the inverse of that. I'm going to have to square root it, and I'm going to do both sides. So the square root of c squared is c, and the square root of 100 is 10. So this missing side right here is 10. Okay, and that's how you find that hypotenuse. Here's a different triangle, but it's a right triangle. It's a little smaller. It's skewed because I copied it. But again, I'm looking for the hypotenuse because here's my right angle. Here's the hypotenuse, so I know I'm looking for the c. So I'm just going to write a squared plus b squared is equal to c squared. And then I'm going to put the parentheses squared plus parentheses squared is equal to c squared. It makes it easier if you just write the theorem and then just substitute in the numbers. I'm going to go with 15 squared plus 32 squared is equal to c squared because that's what I'm looking for. 15 squared is 225 plus 32 squared. 32 squared is 1024 is equal to c squared. C squared is going to be the summation of 1024 plus 225. That should give me 1249. And then what I'm going to do here is I'm going to square root both sides. Mathematically, I have to do, if I do something on the left side, I have to do it to the right side. So I'm going to square root it. So I get c by itself. And then I'm going to square root it on the calculator, and I get this number. So the square root of 1,249 is not a rational number. It's actually irrational because it's 1,249 is not a perfect square. So I'm going to change this to the approximation symbol and write 35.34. Approximately 35 and 34 hundredths. I'm going to round it to decimal place. In math, the cool part, if it's not a perfect square, just leave it in its radical form. Radical forms mean there's a square root over it. So this is going to be the square root of 1,249, which is an acceptable answer. You do not have to take the square root of it, but if you want, you can say it's approximately 35 and 34. In this case, didn't give us the units, so we're going to leave the units. You can always just write units. So write the or in here. And those are the two acceptable answers for this right triangle. Common mistakes, quickly. You can see this is the first example we did. A lot of students forget that that it's a squared plus b squared equals c squared, so they just go something like this: 5 centimeters plus 12 centimeters is equal to c. So c has to be 17 centimeters. That is incorrect. Remember that the correct theorem says that a squared plus b squared is equal to c squared. And when we get back to class the following day, I'm going to go more into depth why it's a squared plus b is equal to c squared. Today is just about getting familiarized with using the theorem. So remember, you got to square it, and then you got to square root it to get c by itself. Okay, another common mistake is students leave their answer in squared form. So for example, 5 squared plus 12 squared is equal to c squared. I know that that's 25 plus 144 is equal to c squared. So students choose to say c is equal to 169. Again, that's incorrect. You got to take the square root it before you put it back in. Okay. This is the last example, and this is one of the most famous examples where they give you a rectangle and they want you to find the diagonal of the rectangle. Well, you got to find the right angle. Right here, right here. Luckily, we know that a rectangle has 4 90-degree angles. Here's my right angle. So I know that the diagonal is going to be my hypotenuse. So I'm going to use Pythagorean Theorem. Anytime you have a diagonal and a right angle, you know you're going to be doing a squared plus b squared equals c squared. And this one, I'm just going to put it in the parentheses squared plus parentheses squared is equal to c squared because I'm looking for the hypotenuse, which is c, but I have to square to get the square root of it. So then it's 3 squared plus 4 squared equals c squared. That's 9 plus 16 is equal to c squared. 25 is equal to c squared. You got to square root both sides. Square root of 25 is a perfect square, so that's a rational number. So that's going to be the hypotenuse, or in this case, x is equal to be 5. So that's all I have. In review, it's a squared plus b squared is equal to c squared. that deals with the Pythagorean theorems. I apologize for the quick handwriting on the screen. Let me write that a little neater for you. Pythagorean theorem is a squared plus b squared is equal to c squared. And to get c squared by itself, for example, c squared is equal to 169, I'm going to have to square root both sides, so c is equal to 113. Okay, so that's in review. Whisk the video a couple times if you have to, and I'll see you guys in class. Have a good day.